Okay, can I have your attention up here? Guys, today's lesson shouldn't be too long. Okay, 7.1 deals with inverse variation. Inverse variation, I want to make sure that we can kind of distinguish between what inverse variation is and direct variation. Okay, as we're going through today's lesson, you may want to define these things on page 192 of your student journal. Okay, but if we move down there, the inverse variation, okay, inverse variation is in the form of y equals a over x, where a is our constant of variation and it cannot equal 0. Why cannot a not equal 0? Well, you can. It's just if a equals 0, what is that answer? It's 0. And like if I had y equals 0 over x, then that becomes y equals, this is 0. That is no longer an inverse variation. It is a linear equation. Right? It's a constant. It gives you a straight line at y equals 0. Okay? That's why we say a cannot be 0. The constant a is the constant of variation, and y is said to vary inversely with x. So this is key terms right here. Y is said to vary inversely with x. And we're in this format, y varies inversely with x. You're going to see that a lot in the story problems that we do. Okay. All right. With that being said, I want you to get a by itself in this equation. Just down here in your notes, solve for a. What do we have? Kendall, what did you get? Good. X times y equals a. So how do you find your constant of variation? Tell your neighbor. Okay, how do you find your constant of variation? Matt? You multiply x by y. How is that helpful? Well, let's say I give you a coordinate, and I tell you y varies inversely with x. Now, I have to tell you that in order for this to work. So I say, hey, y varies inversely with x, and it goes through the point 7, 2. What is the equation? Well, a equals 14, so what is the equation? Okay, we don't go in a form. We say y equals 14 over x. All right, because we found a. We multiplied x by y to find a. So x times y tells us a. When we do that, we get 14, and we plug it into our formula, or our equation, y equals a over x. Okay, so the one thing, if you're going to write a direct variation, or an inverse variation, excuse me, if you're going to write an inverse variation equation, the one variable you must have a number for is a. Okay, how you find a is you multiply x by y. That also allows you to see if things are inverse variations. For instance, if I gave you a table and I said, well, there's 1 and 7, 2 and 3.5, 3 and 1.6, 4 and 0.3, 5 and 0.1. Is that an inverse variation? Well, talk with your neighbor. Is that an inverse variation? Why or why not? Okay. Hey, give me some thoughts. How many say yes? How many say no? Okay, why is it not? Emily? Good. You'd have to be able to multiply x by y and get the exact same value. So here you do. It's 7. Here you do. It's 7. And then I was like, I don't know what 3 times what makes 7, so I started making up numbers. Okay, so 3 times 1.6, that's 4.8. At that point, I know it's not an inverse variation because they're not the same. All right, I want you to make up your own inverse variation right now. Your own table with an inverse variation. One that works. One that is an actual inverse variation. That would be an example of one that's not. That's okay, Kinsey. I understand. Kinsey's eating Thin Mints. Actually, I have a bag of milk. All right. So, inverse variations. Anyone have a table that'll work? Matt, what do you got? Good. Works out. They all equal. A would equal 18 all the way down. Good.
What do you do for 0?
Good question. Hey, if I put 0 in for x, so it's a great question, man. If a over x, what about 0? So that would be y equals a over 0. What's what? Well, in fact, we know a is 18. 18 over 0, what do we get? That is undefined.
Undefined, I knew it.
Of course you did. Okay, now look. You guys, 2 things to remember. First thing is, if you have undefined, we get what's called an asymptote, which means our graph will never hit that line, just like we studied last chapter. So that's something we'll study later when we're dealing with graphs. Second thing to remember, for those of you who couldn't remember the answer here, you're like, is it 0? Is it undefined? If 0 is over the fraction bar, the answer is 0. Okay? If 0 is under the fraction bar, the answer is undefined. Undefined. Okay, I know what Siri will tell me. He tells me I don't have any friends. Okay? I appreciate that. Or cookies or something like that, yes. And that brings us back to Girl Scout. Yes? You have to just write it in fraction form. Okay, so, ladies and gentlemen, here's what I'd like you to do right now. I want you to take a look at, I need your attention back up here. Take a look at page 193 of your student journal. I want you to figure out which ones are inverse variation, which are direct variation, and which are neither. Yeah, which one?
Direct.
Which, number 10. Well, first, which one's inverse? 11 is inverse. Okay, what is the constant of variation? In other words, x times y, which is equal to a, is 5. All right, they all equal 5. Okay, that one's inverse. Constant variation of 5. If you wanted to write the equation just because you're a super achiever like that, you go 5 over x and you'd be done. Perfect. Okay, now, which one is direct? 10 is not direct. 12 is direct. Now,
Yeah, I knew it.
yeah, of course. What? How do you know if something's a direct variation? And you have studied this at least twice now. You studied it once this year and in algebra. Jacob. Almost. You do divide. You don't divide x by y. You divide. What is y divided... Hey, pay attention. What is y divided by x? Not the number. What do we call y over x? We call that rate of change or slope. Okay? So when I divide these two, that divided by that, how many halves are in 2? 4. How many 1.25s are in 5? Yeah, let's just go with 4. Those for sure are all 4. That means my slope is 4. The other key piece to a direct variation, there's one other key piece. It's not every linear equation is direct. There's one special linear equation that is direct. Okay? What's the other piece that we need? What happens when x is 0 here? It's not going to be undefined. Y is going to be 0. Okay, so a direct variation, stay with me please. A direct variation is y equals mx plus b when b is 0. In other words, if you don't want the mathese, it's just in the form y equals mx. There's no b term. It's 0.
I have only ever used a semicolon in math class and never used it in English.
Then you're not doing English right.
Probably not, but the point is I use it significantly.
Okay. Hey,
Do you use semicolons a lot?
hey Walsh, I don't want to get into that right now. I want you guys to get through this so we can start your lesson. But that is sad if you never use it in English. You should learn that. Okay, y equals mx. B is 0. Okay, that means if you're graphing it, it is going through the origin. That is a direct variation. Okay, notice on this one, if I do 4 divided by 2, I get 2. 16 divided by 4, I get 4. Here I get 6. Here I get 8. I mean, there's a pattern here. What is my pattern? I kind of misled you the way I did it. How about that times that? Yeah, it's just y equals x squared. Okay, this is neither. It has a pattern. We know the pattern. We actually know the equation. However, it's neither direct or inverse.
Do we say neither or neither?
Both, like potato and potato. Okay, Kenzie and Mackenzie. You know.
Yeah, but that's like a short version of the name. Neither is
Let's not get too picky. All right. Why don't you guys take a look at the next ones, 1 through 9. Actually, the previous ones.
Mr. McCoy, isn't 12 1.25? I mean, 0.25 is not 4 because did you say divide y by x?
Y by x, yes.
And then so wouldn't 0.5 by 2 is 2?
Oh yeah. Unbelievable. This is 1/4.
Okay, I was confused for a second. I was like, whoa.
Yeah, we went x divided by y. Thank you, Jacob. Okay, y divided by x. Jacob gets a dum-dum. Way to be smarty. Okay, 1 through 9. 1 through 9, off you go. Tell which ones are inverse, which are direct, and which are neither. All right, real quick, 1 through 3. I know that you might not be done with all of them, but 1 through 3. Number 1, everyone, direct or inverse? Inverse, yes. Number 2, inverse. Number 3, neither. Okay, how come this one's inverse? Okay, equals 1/3, right? That would be y. How come this one's inverse? Walsh.
Because you gotta get the x and y on one side, and if you did that, you have to multiply x onto both sides, and then do y times x equals 5.
Very good. And this one, why is it neither? Yeah, I mean, we're adding something to it. We're adding a constant. It's that simple. Either multiplying x by y to get something, or dividing x by y, or y by x to get something. If you're adding anything, we got a problem. Okay? Which means, really, when we start seeing those addition signs, we've got some issues, right? So, looking at that, which one do we see addition or subtraction signs in? 4, 6. That it? That's it. Okay, those are both neither. Yep, so we got our -2. Oops, thank you. Yep, because we're adding to get that. Okay, how about this one? Direct. Okay. Yes, ma'am. Well, let's look at it. 6, would it be direct? If you get all the numbers to one side, here you'd have to divide by -8, and then that would give you -8 under here. You have to somehow be able to multiply x by y to get a constant or divide x by y. But since you have an addition and subtraction symbol, you're always going to be adding and subtracting in that problem. How about number 7? That is direct.
I was right. Oh, crap. Never mind.
You sure it's direct?
Wait, no, it's
Yes.
I'm saying it's inverse. It's inverse. It's inverse. It's just the same as the first.
Okay, Dallas. Okay, let's get x and y on the same side. How do we get x and y on the same side? Hey, need everyone focused. Go ahead. Okay, can multiply by 7. So that now gives me x equals 7y. And then divide by y. Okay, that gives me x over y equals 7. All right. What do you think? Is that an inverse? It's definitely not inverse. You sure? Is it direct? All right. Let's come back to that one here in a minute. All right. Hey, we'll come back to it. How about this one? Okay, how do I get x and y by itself? Divide by 6. 0 divided by 6 is? Is 0. Cannot be 0. Therefore, it is neither. Remember, a cannot be 0. Okay, that's bad. All right, that makes it linear, or a constant, excuse me. How about this one? Direct. We can multiply both sides by 9, right? It gives you y over x equals 9. All right. Let me go back to number 7. Let's approach it a different way. Okay, and I kind of ignored Dallas on purpose for a second. Okay. All right. I wasn't trying to be mean, Dallas. Okay, I just wanted to see if I can figure out where everyone's thinking is. On that, how else can I write this problem? So that's 1 over 7 times x. Okay, what is that? That is, it's a direct variation. It's y equals mx, right? It's a direct variation. You guys with me on that? Don't get yourself so turned around. Like when you try to go to y equals form here, or x, y on the same side, you end up with this, which you're like, well, that kind of looks direct-ish. Okay? But just, I mean, look at the format it's in. When you just see x over 7, remember that's 1 over 7x. I know that we sometimes dealing with fractions, we forget these things. Like there's a 1 out there, and anything that's on top actually could be moved out to the side like that. Okay? And that's just your slope then. Okay. All right. Any questions there? Okay, let's go ahead and move on to the next page. Oh, don't want you to look at that. All right. Okay, you get about 2 minutes to do those 4 problems. Hey, here we go. Hey, how do we find A? X times y. It says x and y vary inversely, so therefore you can find a by doing x times y, which in this case a equals 4, 2 times 2. Here a would equal 18. Here a would equal 7. Remember, you put a 1 under that. You can cross cancel, so you get 7. Here a would equal, a equals 5/3. Therefore, my equation, y equals 4 over x, y equals 18 over x, y equals a over x, or 7 over x, and y equals 5/3 over x. That is poor form, Batman. We don't like that one. Okay?
What?
Yeah. That's bad. We don't put a compound fraction. Therefore, when we're rewriting that, think of that as just moving this piece down to the bottom. So it's y equals 5 over 3x. Bless you. Okay? That means the same thing. And now if I'm evaluating it when x is 5, that gives me y would be 4/5. There's Walsh's semicolon again. Okay? And here we put a 5 in, so you get y equals 18/5. Here, put a 5 in. Try to leave it in fractions. I know you don't like it. Thank you. Okay, any questions?
Why do you use a semicolon?
I don't know. Just to annoy me. So we don't think of it as like thousands, I guess. All right, 17 and 18. While I'm handing out your assignment, try those two. Okay, number 17. The volume of a gas is inversely proportional to the pressure P of the gas on its container. Pressure is 32 pounds per square inch, results in a volume of 20 cubic inches. What is the pressure if the volume becomes 10 feet? Okay, so a couple things. First, you have volume and pressure varying inversely. That means V times P equals our constant of variation, right? So that would be our K. The book calls that or A or K there. So we're going to call it A. Okay? And so in that case, they tell us a situation. They say, well, when the pressure is 32 pounds, it results in a volume of 20 cubic feet. So when our pressure is 32, our volume is 20. That will tell us our A. In this case, it is 640. So A equals 640. That allows us then to write our equation. Y equals A over X, or 640 over X. That then allows us to evaluate when the volume is 10. Well, which one's volume? X or Y? What's that? Doesn't matter? You sure? Hey guys, I'm really not trying to be difficult here. I just want to make sure that we're clear. If we just leave it as V times P equals 640, and I say, okay, I know a volume, I want to know the pressure, I would have to get P by itself, I'd have to divide by V, right? Okay, well, and by the way, I could do that. I could put the 10 in here, and I get an answer of, I get 64. Okay? Now, and that would be PSI, okay, pounds per square inch. Now, just so that we can answer the question we just asked about X and Y, look, if I'm in this format and I want to get V by itself, what do I divide by? So did it matter? It didn't matter, no. Okay? Nice job. Okay, I would leave it in this format to plug things in, but if I'm writing the equation, I'm writing it out in that format. Okay. All right, number 18. Why don't you guys go ahead and complete that one? I'll put up the answer here in a minute. Okay, the answer to number 18, there it is. 14 days. Oh, yeah, I got it. Okay. Use the 20-day crop for 7 farm workers to get A equals 40 or 140. You plug it in, and you got it there. T equals 14 days. Any questions?